Welcome to our channel, Rank 1 Academy. It is one of the leading institute in Chennai. Today we are going to see optical sensors and their applications. Day-to-day life, we are seeing so many sensors and so many applications involved. Today in our concept, we are taking optical sensors and their applications. Now, what are the topics to be covered? Introduction, why optical sensors, principle of optical sensors, classification and comparison, some interesting applications. Where do we go from here? Introduction, new revolution of optical fiber sensors. It is a spin-off from other optical technologies, seeing the potential in sensing applications developed as its own field. So, these optical sensors play a very vital role in today's communication world. Why optical sensors? What is the advantages of these sensors? Okay, electromagnetic immunity. The first important thing that is electromagnetic interference. So this optical sensor capable of handling this electromagnetic interference. So we can contrast India's electromagnetic immunity. Then electrical isolation. Then compact and light. The optical signals here we are using laser, which is very monochromatic. Then both point and distributed configuration, wide dynamic range, and amenable to multiplexing. Because of all the reason, I go for optical sensors. Now, what are the measurements of optical sensors? Temperature, pressure, flow, liquid level, displacement, vibration, rotation, magnetic fields, accelerations, the corresponding chemical species, force, radiation, pH value, humidity, strain, velocity, electric fields, and acoustic fields. Now, what about the working principle of this optical sensor? Here we are having that optical source, which is fed by here they're using feed fiber, now which is given to your measurement zone. Then the output of this measurement shown is given to your optical detector. In between this region, what are the characteristics of this fiber and the optical signals get changed? This is what our analysis. So the light beam changes by the phenomena that is being measured. The light may change in its 5 optical properties, such as intensity, phase, polarization, wavelength, and spectral distributions. Now, what about the sensing details? What are the property it going to sense? First one is intensity-based sensor. First one, we are going to see the sensing details. EP of t into cos omega t plus theta of t. Here, the EP of t is nothing but intensity of your optical signal. And this omega term, it is determined your frequency of your optical signal. Then modulation, phase modulation sensing, that is determined by using this theta of t. Then polarization modulating fiber sense. So these are all the parameters we are going to measure under this. Now, what about the classifications of sensor? Here we are classified in extrinsic as well as in intrinsic. In extrinsic sensor, where the light leaves the field or transmitting fiber to be changed before it continues to the detector by means of the return or receiver fiber. So this is what the diagrammatic representation. Now, what about intrinsic sensor? In intrinsic sensors are different in that the light beam does not leave the optical fiber, but is changed while it's still contained within it. So this is nothing but intrinsic sensors. Now, what about the comparison of these two sensors? Extrinsic sensor applications we used temperature, pressure, liquid level, and flow control. And here in intrinsic, rotation, acceleration, strain, acoustic pressure, and vibration, which is less sensitive. Here it is more sensitive. easily multiplexed here through a tough to multiplex, ingress and egress connection, here reduce connection problems, easier to use, more elaborate signal demodulation, less expensive, more expensive. So these are the difference between these two types of optical sensors. So we are using so many applications. The sensor types: chemical sensors, remote spectroscopy, groundwater and soil contamination, major players in chemical sensors. So what are the things it is used to? In Pharmacia Biotech in Sweden, Fiberchem, and the Quantum Group. These are the companies they are manufacturing this chemical sensors. Now, the temperature sensors, largest commercially available sensors, range 40 degrees Celsius to 1000 degrees Celsius. And small companies, Japan and Hitachi and Sumitomo, are manufacturing this type of sensors. Strain sensors, fiber graduating technology is used in this strain sensors. It senses little as 9 micron strain in this object. So now they are using the NRL and United Technology Research. They are doing manufacturing this type of sensor. Biomedical sensors, spectroscopic biomedical sensors, as carbon dioxide, O2, and pH can be measured simultaneously by using this biomedical sensors. Flow monitoring by laser dosimetry, the fibers ophthalmologic applications. So many applications we are using this biomedical sensors. Electrical and magnetic sensors, appealing inherent dielectric nature, less sensitive to electromagnetic interference, small size and safer. They are almost always hybrid in nature. ABB Corporation Research Center, they are doing this kind of sensors. Rotation sensor based on Sagnet effect, two type ring laser gyroscope and fiber optic gyroscope. US companies pursuing high performance FOGs, for an example from Honeywell, Litton, Northrop, Allied Signal, etc. These are the companies they are doing research and they are manufacturing this kind of rotation sensor. Pressure sensors. Earlier based sensor piezo-resistive techniques based on movable diaphragm, high performance it will produce. That is the polarization based sensor. This pressure sensor is polarization based sensor. Then operating pressure ranges from 0 to 70,000 torr. Displacement and position sensors, one of the first opto electronic sensor to be developed. Simple sensors rely on the change in retroreflectance due to a proximal mirror surface. These are the principles, also referred as liquid level sensors. So this type of sensor also mostly we are using in day life. Then applications. First and the most important application is military and law enforcement. You see the sensor. This sensor enables low light imaging at TV frame rates and above without the limitations of vacuum tube based systems. Night vision camera comprises of amplified CCD sensors, anti-blooming technology, crystal polymer shutter. And advantages of this type of sensor: exceptional day-night resolution, immunity to overexposure, very high contrast levels, no holing or scintillations. Biometrics, your face, fingers, and eyes in a whole new light. Image capture, image processor, feature extraction, and feature comparison. Partial discharge detection uses optical fiber sensors. Optical fiber sensors are being tested for use in detecting partial discharges in electrical transformers. Pinpointing such discharges is essential to preventing insulation breakdown and catastrophic failures. Conclusions: looking at the industry trends, in the past 2 decades, and the exponential curve, it seems to be that there is going to be a lot of research and improvements to the existing sensors. Optical sensors are here to stay. Once you like this channel, kindly like, share, and subscribe this channel. Thank you.